Hey, you tens. Welcome to exercise 17.8. I'm not quite sure what that was from Zoom, but yeah, it is being recorded. So this is our last exercise for the semester, and yeah, I hope you've had a great time. Now, this basically summarizes everything we've done throughout linear equations, quadratic equations, and polynomials into one, essentially. So using everything we've learnt, in 17.8, we learn how to solve polynomial equations, which means finding the x value or the x-intercepts. So there's a fair bit of factorizing. I won't go through this little blurb here at the top. You can read that in your own time. But I will mention that we are going to apply the Null Factor Law again. What you'll notice is often we'll get 3 brackets, unlike quadratics where we got 2. Or often a term on the outside of the bracket and a bracket in itself. Again, the null factor law applies because even if we have 3 brackets in this equation where they're all multiplying together, one of them or all 3 of them or 2 of them will have to equal 0 for this equation to hold true, since the null factor law states that it equals 0. So same sort of concept, same sort of logic. Let's see how we apply it to some polynomial equations, specifically cubics to the power or degree of 3. I forgot to put lines. Give me a second. And we're back. Right, so the first step to solving polynomial equations is just to check if there are any common factors between the terms that you're given, and also to make sure that on one side of the equal sign it's 0. So for example, in 1a, we've got x to the power of 3 equals 9x. The first step is just to rearrange it so that we have this 9x move to the left side of the equal sign. So we have, therefore, x cubed take away 9x equal to 0 as our equation going forward. Now, as I mentioned, check for common factors and see if you can factor them out. So what you notice is between x to the power 3 and negative 9x now, both terms have the pronumeral x. So we can actually factor that out. And then if we factor that out, well, we have to think about what's x to the power 3 divided by x. That's x squared. And then we can double check if x times x squared gets us x to the power of 3 or x cubed. It does, so we factorized it correctly. And then we divide negative 9x with the highest common factor, which is x here. So we're just left with negative 9 equals 0. Okay, so once we've got this, this is a difference of perfect squares, okay, because of the 9 being a perfect square, and then we don't have an x to the power of 1 term in the brackets. So we can essentially split this into, well, the x just gets carried down. We're going to have an x plus 3. That looks like a k. Let me just redo that. Going to have an x plus 3 brackets and then an x minus 3 brackets equal to 0. As our 2 brackets, which are factorized from the x squared take 9 due to the difference of perfect square rule. Okay, so this branches out into these 2. And so we didn't actually have to long divide here. We just factored out the highest common factor between x cubed and negative 9x. And then we realize, hey, we get a quadratic of x to the power 2, which is quadratic, take 9. So we can use the difference of perfect square rule to basically square root the 9, and we get plus or minus 3 since they multiply together to get you the negative 9. And it also makes sure that the bx term is cancelled once we expand it. All right, so if you're unsure, just double check for the proof. So this means we're going to get 3 variables. We're going to get a situation where we've got x equals 0. Okay. X equals negative 3 using the null factor law. And then we've got a situation where we've got x equals 3. All right, so in other words, I guess our intercepts are going to be the origin, negative 3 and 0, and then 3 and 0. Okay, that's all you need to do. So find the values of x. I'm sure you're familiar with long division, which is, I think, this example out here. B, I don't think we have to long divide, mainly because remember the first step you always want to look at is if the 3 terms or the 4 terms that are given have common factors. And here we do, okay? And if you can take out a negative, you always want to take out a negative for that common factor. Okay, so here, what we notice is 2, 4, and 70, they're all even. Okay, so that means they're all divisible by 2, meaning we can take out a negative 2. And we can also take out an x because each 3 terms have an x, and you always take the lowest power because that's going to be the only one that's appropriate because it's the highest factor and the lowest common polynomial with the lowest power between the 3. Okay, so we just take out 1x instead of x to the power 3 or x to the power 2. Okay, so we just take out the x to the power. So from here, we just divide the original 3 terms by negative 2x. So negative 2x cubed divided by negative 2x gets us positive x squared. Positive 4x squared divided by negative 2x now flips this into a negative 2x. And then we have positive 70x divided by negative 2x. This will get us negative 35 equals to 0. And what you notice is this is still the original equation, but we've now taken out a common factor, that's the highest, from all 3 terms. And inside the brackets, we've got ourselves a quadratic, just like we did in example 1a. And just like we factorize on division, when we find the quotient or the answer, we get a quadratic. So this is where our I guess factorizing skills from quadratics come in. We check to see if there's factors of negative 35, which add to negative 2. And so let's just carry this down first. Let's have a think. Do we have, so we've got 2 x's. One's going to be a plus, one's going to be a minus, because to get a negative 35, we know it has to be a positive number times a negative number. And then we just have to think about, well, what number gets us negative 2? That's a factor of negative 35 when we add them together. I think we roll with a negative 7, and we roll with a 5, because negative 7 plus 5 gets us a negative 2. 5 times negative 7 gets us negative 35. So this means we're going to have a situation where we have, again, x equals to 0. This here we've got x equals to negative 5. And this here we have x equals to 7. All right, using the Null Factor Law. Now, if you've forgotten, that's just having each segment of the equation equal to 0 and then use your linear equation to solve for x. Now, what does this mean? We're going to once again have an intercept at the origin, an x-intercept at negative 5, 0, and an x-intercept at 7, 0 as well. Right, let's take a look at example 1c. This one here, okay, so straight away what we notice is we have a negative 11, and that's a prime number. So it's going to be very rare that we're going to get all the other numbers. That's going to share the prime factor, I guess. And so here we don't actually have a common factor between any of the 4 terms. Okay, so yeah, I'm guessing here we have to long divide, unless you can see it's short divided. No, let's long divide. Okay, so what we need to do is we need to use a remainder theorem to find what our divisor is. So therefore divisor, So let's just write steps out. So step 1. I'm sure you're familiar with these steps. We've done this before, but just to consolidate. Step 1, okay, use remainder theorem to find the divisor. Okay, so the remainder theorem goes like this. We trial and error. Let's try the number 1. Okay, so it's not going to be 0 because we plugged in 0 to all the x's. We're going to get -9. If we were to plug in 1, and if the answer equals 0 using our remainder theorem, we know that then is going to give us our divisor for this expression here, which means we found essentially one of the factors. So here we've got 2 times 1 cubed, take 11 times 1 squared, plus 18 times 1, take 9. If this equals 0, we found ourselves the divisor. So here we've got, well, 1 cubed is 1. So we've got 2. 1 squared is 1. We've got -11. Here we've got +18. And then -9. So 2 take away 11 gets us -9. Plus 18 gets us +9. Take away 9 gets us 0. So again, our try and error, we've managed to save a lot of time since our divisor is actually x take away 1. X take 1. All right, and from here we go and do long division. Step 2. All right, we do long division because, well, it's a factor that's not going to give us a remainder, and we can eventually get our quotient. That's probably going to be a quadratic to go and figure out the rest of the x values. All right, so let's long divide. Sorry, guys. Okay, so we know it's x take away 1. That's our divisor. And inside the division sign, we've got our dividend of 2x cubed, take 11x squared plus 18x, take 9. All right, and then we use our steps that I'm sure we're familiar with. Let's start with yellow. We look at just the x's. And we think to ourselves, what is 2x cubed divided by x? This gets us 2x squared. Let me just double check the divisor is x take 1. Yeah, it is. We multiply this back, we get 2x cubed. Now we're subtracting here. Take 2x squared. All right. They cancel. We've got 2 negatives. So now we've got a situation where we've got -11x squared plus 2x squared because of the 2 negatives, which means we get -9x squared. And so we then take a look at the x again, and this -9x squared. This gets us -9x. And so we multiply this back, we get -9x squared. And then we've got a subtraction situation. We've got +18x because of that dragging down. And a +9x. because negative 9x times negative 1, positive 9x. All right, this here divides, and the x squared terms cancel out. 18x take away 9x, we get just 9x. A lot of 9x's. So we then go and divide the 9x by x. We get ourselves positive 9. All right. Yeah. So let's just double check if this is correct. So 9x times x gets us 9x. They will cancel. We drag down the negative 9. Positive 9 times negative 1. Negative 9. Okay, 2 negatives. So negative 9 plus 9 gets us 0. And we have ourselves our quotient. So step 3, factorize accordingly. Factorize, use. So let's write factorize quotient. Okay, so the answer we got above, we can factorize. So therefore we have x take 1, 2x squared take 9x plus 9. And then what we notice is we've got ourselves already one of the x values, which is positive 1, but then we have to factorize the 2x squared take 9x plus 9. Let's see. Let me see what the best method is. Right, so we're back. Yeah, there's a slight error here. So this one should have been a plus 9x, which makes a lot more sense because if you recall, back when we were dividing just the green part, so negative 9x squared divided by x, this should have given us, hang on. Should it? No, disregard that. I was right. Yeah, that's fine. There's no errors here. So I guess we can just figure this out. Just thinking of factors. Factors of 9, that's positive. But because we've got a negative 9x here, it has to be 2 negatives. I can't see it being 1 negatives. That's just going to blow it out. Since we've got a 2x squared here. So what if we try 2x and x? So if we expand this out, 2x squared, negative 6x, negative 3x, so negative 6x, take negative 6x, take 3x, gets us the negative 9x. Negative 3 times negative 3 gets, hey, positive 9. Yeah, we got it. So no need for the quadratic formula here. But when in doubt, always use the quadratic formula if you're unsure. But here we've got ourselves, I guess, the two brackets, which are the factorized version of 2x squared take 9x plus 9. And then we use a null factor law to figure out this here is going to give us x equals to 1. This here will get us, well, using linear equations, we get 2x equals 3, therefore x equals 3 on 2, or 1.5. And over here we've got x equals to 3. All right, wasn't painful after all. And look, we've been doing enough questions now to get basically the 3 brackets. Now it's just taking that step further to find yourself the x values. Okay, that's all for exercise 17.8. Let me know if you have any questions.